Hello everyone, my name is Daniel Allen. This is my EEE120 Capstone project, which is an airport terminal tram controller. This state machine, a quick summary, will move passengers between 16 gates labeled 0 through F in hexadecimal and are displayed on this 7-segment display here. The controller responds to a 2-bit input C, which are these two inputs here, C1 and C0. 0, means to stop at the current gate, 0, 1 means to move up one gate, 1, 0 means to move down one gate, and 1, 1 means to move two gates in the same direction before stopping. This is design 2 of my 2 design propositions. I chose design 2 specifically because of that last 1, 1 movement system. It is that was sort of suggested by my stakeholders. They liked that idea, and that won out in the end. That sort of barely beat out the other one though, because the other one was a lot simpler. It was less complex. It did not have as much functional completeness. The output logic simplicity of this one is actually a bit simpler, which we'll get into, but the other stuff, it sort of goes between the two. So, but it only barely won. So I will sort of show you now how everything works here. So the inputs, right, C1 and C0 are the control inputs, like I just said. Clock and reset will just clock the ALU and the register to make it go in the direction that we need to, and reset will reset the whole machine. The combinational logic here, which is this whole thing, calculates the next state, which is D2, D1, and D0, and then these 3 D flip-flops here store the current state using Q2, Q1, and Q0, and they all have asynchronous reset. The output logic here is very simple. So A0 is equal to Q1 and Q2, or Q1 or Q2, sorry, and this tells the ALU to move. Invert will basically just invert the direction that you're moving using Q2, and green equals to Q2 not and Q1 not, and then red is obviously just not green. Green means the doors are open, red means the doors are closed. So red is like you're moving, green is you're stopped, and the door is open. The ALU and the 4-bit register track the current gate position displayed on the 7-segment display, and we will now get into the demonstration. So it's hard to show the reset and the 0, 0 before I show anything else. So I'm going to show you 0, 1 first. So as I said earlier, 0, 1 will move up 1. So I'm going to clock it at 0, 1, and that is going to close the doors to indicate that we're moving. And I will clock it again, which indicates that we've just moved to station 1, and we have stopped the tram and the doors have opened. And I can keep doing this over and over, moving, stopped, moving, stopped. And now let's say, right, let's say like I'm moving, disable this, it'll move up and stop. So that's just what 0, 0 does. It just basically stops you, and it doesn't allow you to keep moving. So like I can keep clocking over and over, nothing ever is going to happen at 0, 0. And now I'll show reset really quick. Reset is just going to reset the entire machine with this 4-bit register here. And now I will show you 1, 0, which is the opposite of 0, 1, and that is going to move it backwards. So moving and stop at F, moving, stop at E, moving, stop at D. And that'll go all the way around. It'll wrap around all the way back to 0. And now the main reason that I chose this design too, which we talked about earlier, is this sort of double movement option here, where let's say we were just moving in the direction backwards, and now I select 1, 1. If I clock this, we're going to be moving, and you see we've hit this next station C, but we're still moving. The tram has not stopped yet. We do it one more time, and the tram has now stopped at B. So it's moved 2 before stopping. And it's going to keep doing that in that direction, right? Passing 8, stopping at 7. Passing 6, stopping at 5. Passing 4, stopping at 3. It'll keep doing that over and over all the way around, wrapping all the way around. Just like that, right? And I said it's based on the last position that you move. So let's say we move up a floor, up a station, right? E. And we now do 1, 1. Now we can move up instead of down. So here you see where we are going to pass 1, stop at 2. Pass 3, stop at 4. Pass 5, stop at 6. And that's basically the reason that I chose this over the other one, is it's got that cool move 2 in 1 function. And honestly, that's basically everything to show you. There's not a whole lot more to this. It's very, very simple. Yeah, all of these tunnels are all these like input tunnels here, which are controlling this that's controlling the entire like machine, basically. All the inputs are based off of, you know, all these other tunnels that are receiving the signal and then sending the signal back out. So yeah, that's pretty much it. I've shown that this can wrap around, do everything that I say it does, and I've got even all of these K maps. I've got the state transition tables for both machines, or both designs. So this is, yeah, these are the ones for design 2. State definition table, my state diagram, and then this is for design 1. So I've got it, yeah, in order: design 1, then design 2, and all my stakeholders at the top. So yeah, that's everything. So thank you for listening. Thank you for watching.